Okay, welcome to the IIMuse podcast. It's a new video podcast by Pedro and Rocky Regan. I'm going to introduce Pedro to you. I knew him while I was in the regiment. We'll talk about that in a minute. We've been friends for quite a long time. He was the reason why I got a degree. When I became a single parent back in I think it was 1990, wasn't it? Yeah, 1990 or 89, 90. When I met Sue about 6 months to a year later, she was already a teacher and I had no formal education at all. And she persuaded me to get some GCSEs and also go for the equivalent of an A-level, which I was doing. But it wasn't until I met Pete again later on that he persuaded me to do a degree, and it was life-changing, really. So he's a great bloke. We have a strange relationship because we are politically a bit different, although not as much as we probably shout at each other about. Basically, we've had quite a few rows, particularly on our other channel in the early days, being a screaming lefty teacher type, but I'm not really any more. And we also used to have some robust debates while we were in the military. But, like I said with the tagline, we may be very different people, but we can still remain friends, and we're really good friends, and we have some really good intellectual debates. Pete, over to you. Do you want to sort of say something as well?
I think you've played up the "we always fight" bit too much.
Are we going to have a fight about that? Okay.
I think we have a very similar background, Steve. I think, when I joined up, I had very minimal education. I took CSEs. I got a couple of decent CSEs, actually, but one of which was equivalent to an O-level. But I had a real problem with education. I knew that the old chalk and talk approach to learning didn't work for me. And all these years later, it took me ages to work out why school education didn't work for me. And it's all about, oh God, you're an educationalist, so I can't really talk technically, but I think I'm a kinetic learner.
Yeah.
Which means I think that means that I like to get the book, pick it apart, make mistakes, hands-on, break it, put it back together again, and learning by doing. And that doesn't work at school when you've got loads of people and teachers haven't got time and they're just going to move on quickly. So I was probably very slow at school, but I didn't realise there was a bit of a moment in the military where doing a 81mm mortar course, I was asked by Colin Taylor, who's on both. He might be on both of our friends lists. He might be listening to this.
All right.
He said, "You can guard the mortars over lunchtime." And I went, "Oh yeah, no problem." And what I did was I used that opportunity to practice, and all I did was practice, and I became really good. And I then became, as an LAC, the number one on the pivot mortar, which would take years to people to practice. And basically, number one needs to be the fastest and the quickest in laying the mortar, so to get around down the range. And I suddenly had a light bulb moment going, maybe I just need to work harder than everybody else and put more effort in, and I'm not really that stupid. I just need to practice or train or rehearse more and put more effort in. And I still think about that now. It was a real change in my life. So then I applied that to RAFET 1. I was always crap at maths. I noticed on the description you have me as mathematician. Nothing could be further from the truth. You are much more numerate than I am. Naturally.
But part of your degree was mathematics, though, wasn't it?
The first degree, when I started with the OU, I did M101.
And didn't you work for Price Waterhouse Cooper as well?
Yeah. So, you know, I'm in the consultancy part, not the accounting part. So I did M101, which was the maths entry. You probably did M102 by the time you did it, did you? You would have had to do computer science, I think.
I did a technology course.
Right, T102 probably.
Yeah, well, by the time I came along, they'd moved on to named degrees, and you had a more solid path.
Yeah, so they just introduced that when I finished mine. So my degree is called Computer Science and Systems.
Mm-hmm.
So I think yours was a bit more of the computer science. I only did so many computers. Anyway, just to go back a bit, I did RAFET, failed it, did it again, passed it, and the only difference between the two is I got the books and I just read it.
You might need to explain what RAFET is, because we'll have Army and all sorts here. They won't know.
RAF education test, basically. So if you want to go for promotion, you have to, and a lot of people fall at this hurdle, especially if you come out of school with very little in terms of maths and English. I've always been okay at English, but maths has been a big bugbear for me all my life. Anyway, so it's basic maths, nothing much. Had to know your times table and that malarkey and a couple of simple equations. So I did that. I then did the second part of that, RAFET 2. Again, applied the same ethic to that. Just don't learn it from people, get the book, learn it yourself, practice, pass that, and then decided, sod this, what am I going to do when I leave? So I then decided to do a computer science degree, did the maths, M101, the computer science degree or elements of that degree, the maths in that is quite difficult, or it was for me. Steve probably found it easily, so calculus and all of that, and derivatives and integration. Again, you know, it feels like it's not really maths as we know it, but just practice, and sort of got there. So anyway, I finished that, and Steve's looking at me going, "You're thick, how did you do that?" And I went, "Well, Steve, you're much more intelligent than me."
I didn't say you were thick. I didn't say you were thick. I didn't say you were thick. No, I tell you what though, because I did extra time on my degree because I did a project for the British Computer Society at the end, and I had to do a further dissertation in artificial intelligence. So I did Prolog and neural networks, and I built a number plate recognition system, which, when you think about when I did my degree, there wasn't the computing power to do that. So I remember handing in my dissertation and saying that my software did I built the neural network, I had the predicate logic language all built, the rule base and everything like that, and I trained it to pattern recognize all the data, all the different letters on a number plate, and it only worked 33%. And I sent it in, and I went, I evaluated it, because the last thing I had to do was evaluate, and I said, I've done everything right. It's just, I don't think it's got enough computing power to run the neural network, because, you know, it's a graph, a massive graph with weighted mathematical things in it. And basically that I got a distinction. I got a distinction because they said that, as you know, computer science is more of a science than it ever has been now, particularly with AI, the way it's going, because one of the criticisms I get from the physics department and other people at work is that, I mean, they're just being flippant, computer science isn't a science, but it very much is now, because they're having to work with neurologists and biologists and people like that, and they do a lot of experimentation and a lot of trial and error and failure using the scientific method in order to do it. So it's cutting edge science, really, AI. This is a really good segue, actually, that we're going to move on to talking about our next piece now. Okay. We're going to go on to the topic of the evening, which is artificial intelligence. Now we both, I would agree, come at this from a different angle, because I teach it, or at least it was on the A level syllabus. I teach or I taught prologue, and I also discuss the ethics of AI, and I also talk about robotics. I've built a few robots myself using Raspberry Pi, Arduino, and I had a strange one. I had a Lego dog. A Lego dog. You'll like this, because it really sums up. Now, what's that humanoid robot? What's it called? It begins with S. The female robot that's going around. Can you?
Sophia.
Sophia, yeah, Sophia. It's the same effect. Most of that Sophia is typed. They're typing the responses, or it's got some AI and neural networks, but it's not really an AI machine. It's a bit of a art project, I call it, because it looks good. They're looking at the way a computer can, a robot or a humanoid robot can interact with a human, and you know it's a facial expression, but the technology behind it is API. So it's just connected via software, and it's not really part of Sophia at all. It's actually, she's attached to some networks and grids to actually do that, but most of it's rehearsed, set questions. And I had a Lego robot, and I designed it in C. I'd written it in an old language of C with a bit of prologue, but all it used to do, the only thing it did, was if you shouted at it, it backed off and whimpered, right, this thing. And when you ran at it, it had a light sensor, and it used to scurry off, and then it used to come back tentatively and follow you around. So it had a sensor, and it followed you around. So I did 5 things. It had 5 sensors. It had a touch sensor. It had a noise sensor. It had a sonar. It had other. I can't remember all the sensors now, but it had 5 sensors. And basically, I used to take it into secondary schools and show them this. And one of the things that I did as a sort of party piece was to be cruel to it. I used to be cruel to it. Just I'd go along and give it a name. I'd build up a rapport. It would do all the things, endearing things that a dog did, albeit made of Lego bricks. And it used to move its head, and its ears used to flap up like that. And then I'd start being rotten to it. And the reaction from the audience was shock and horror, because they'd anthropomorphized it. They'd put a layer of this thing is real, but the thing was procedural programming with a bit of predicate logic. There was no neural network, so it was no memory. It was just running off a rule base and an algorithm. It wasn't even object oriented. It had no intelligent agents with it. It was just straight programming. So this thing was, it just shows you that people get fooled. There's a lot of people in the AI world that think Sophia is giving the wrong impression because robots aren't like that. And it's not interesting to me, because I'm not after a command of data. I'm after the neural connections with humans. Basically, transhumanism is what I'm more into. So that's my sort of side. I look at I think it's not AI I look at, it's AGI, artificial general intelligence. And for those people out there who don't know what that means, it's a branch of AI, which is, because AI, if you think of a big circle that encompasses machine learning, deep learning, all the other aspects that you see in AI, AGI is human characteristics. It's trying to make artificial intelligence more human, and therefore interact with humans. So we can merge with it, or we can make humanoid type mechanisms. Even things like Siri that talk to you, it's all and people that play games with it, it's all about that. But you come at it from a different angle. Tell us about your sort of dealings with AI.
Well, I can talk about AGI as well as, and that isn't actually, I've got a picture of the future for that, the same as you, and I'm very interested in it, but it's a generation away. Most experts think it's at least a generation away. It's the narrow AI that I'm working with. Might be worth saying hello to a couple of people here, actually. So I was doing all of this, and actually by the time I came to a couple of years out from leaving. I was doing the MBA, and just imagine the frustration I had in the last couple of years of service, having done an MBA and having to deal with people like Joe Corns. Hi, Joe. How you doing? Richie Coleman, he was there as well. He was a good lad. Richie's very clever, very sensible, and kept Joe on the straight and narrow. Anyway, I just thought I'd drop that into those guys. Right, let me just...
I've just said hi all as well. There'll be a bit of a delay. I don't know how much of a lag there is at the moment. I can see it. I'll monitor the lag. But anyway, so we've got about 10 people watching at the moment. Can you just talk about your presentation now?
So I'm just going to flick through a couple of these, right? So this is a presentation I do. There's a couple of things I do. I used to be in PricewaterhouseCoopers. I was there for 15 years. I left in 2015, but I go back and I talk to the graduates about the new graduates in technology, about AI, automation, and what that might mean for them. I'm also what they call a shaper for the fourth Industrial Revolution challenge, which is part of the World Economic Forum piece of work that they're doing, which is basically going around organising workshops and talks about AI in different industries and different parts of the economy. So this is some of the stuff that I do. The big driver behind this, Steve, is not, we've had a couple of what they call AI winters where people have got very interested in AI. It's got massive investment from the people that have the money, and then they back off because the technology breaks or it's not the right time. But this time there's a real urgency for it. What people don't realize is that we're not procreating as fast as we should do, and our birth rates are going down, which means as people like you and I have built the economy and opened it up, people behind us are having less children. So the graph you can see there is just a bit of research in Northern Ireland. In 1920, we were having per 1,000 people, 26 kids. But it's only 12.7, 13 in 2016. So essentially, we haven't got enough people to maintain the economy. So what we've got is various countries around the world have got a shortfall. So the column on the right is the percentage of shortfall that we've got in workforce or in labour numbers. You can see that Russia has a 24% shortfall, Brazil 33%, Canada 11%, France is okay, maybe 1%, Germany 23%. And this is driving a lot of the politics that's going on at the moment in terms of immigration, all right? You look at Germany and it's building up its population by open borders is pretty good for Germany because they've got a shortfall. Their economy is going to suffer. But at the same time, they're investing in automation driven by AI. Now, you've talked about the general AI. The other thing that I talk about generally when I do these talks is what's the difference between the narrow AI and the general AI. I just flicked right through that very quickly. So a general AI that Steve's already talked about is otherwise known as a super intelligence. It's conscious, sentient, it supersedes human performance in all areas. Whereas the narrow AI supersedes human performance in a very, very narrow set of skills, one or two tasks. And then people say, what is AI? Well, there is no pure definition around AI, but Tesla's theorem, and it's not the Tesla that you might think of that was the subject of the film just recently, over 100 odd years ago. It's a academic based out of MIT, talks about AI. It's something that hasn't been invented yet. It's just beyond our reach. And 10 years ago, a good spam filter, which is actually a narrow AI, a bit of machine learning, when it was out of reach, we would have talked about that as being AI. it's not AI anymore. We all accept that our spam folder gets filled up with stuff. We just go check it every now and again, make sure it's picking up the right thing. Well, that's a bit of machine learning, or what you could call AI. This for me, I drew this and put it on my blog a number of years ago, probably about 2 years ago. Bit of research and tried to answer the question, what is a narrow AI? And that diagram really describes it. Now, for me, there's a number of bits of technology that that are useful in their own right and are subjects and very technical and subjects in their own right. And there are experts in those fields and there's work going on. But essentially, they're how we interface with the piece of intelligence. So things like machine vision, image recognition, text-to-speech, expert systems, etc. These are all for me, how we interface with the artificial intelligence. The brain of the artificial intelligence is the top of that, machine learning, which consists of deep learning and predictive analytics, and there's a huge amount of work going on in that space, and it's coming on in leaps and bounds all the time. So that for me is what the heartbeat or the brain of artificial intelligence is, and the other areas, challenging as they are, NLP, natural language processing, and vision, is just how we interface with the piece of technology.
Okay.
Let's flick into this stuff. Sorry. So I'm doing some work at the moment myself into machine learning and predictive analytics, and there's a couple of great examples that people have probably heard of. One is IBM Watson, that won the game of Jeopardy a number of years ago now. And the way it did that was by what they call an ensemble. So they had IBM created a team of machine learning, deep learning experts, but they were finding that on a previous database of questions, they were only getting 50% of those right. So what they did was they built 5 teams who had different models, and that, by the way, is very similar to how we fly airplanes and navigate fly-by-wire at the moment. There isn't just one computer or one system. There's a number of systems that actually overlap themselves. And what they did was that Watson had what's called technically an ensemble of ensembles. So essentially all it does is goes out to the internet, and that's called the corpus of knowledge. And if you know Jeopardy, basically Jeopardy, you get the answer and you have to find the question. So Watson was able to go out to the internet and, using 5 or 6 different algorithms and machine learning algorithms, come to the conclusion, and it basically won it. And Celeste and Doug were 2 previous championships. And that, so, people think and talk about artificial intelligence. It isn't really. It's pure maths. It's machine learning, which uses algorithms and predictive analytics, and it's basically statistics. So all it's doing is the algorithm, or one of them, is picking the answer that has the highest chance of being right. Another great example is a lady called Jill Watson. That's not Jill Watson, actually. You might recognise that.
That's out of Battlestar Galactica.
It's the lady out of Battlestar Galactica. That's exactly right. I knew you would know that.
Anyone who's into toasters.
Into a human face.
Yeah.
But when students in Georgia Institute of Technology were doing the AI course, they were given an online tutor called Jill Watson, and they were basically able to email her, and she would email back with the answers. A great example of natural language processing piece of work, which is an area of machine learning and AI, if you like. And guess what gave her away? She lasted about 4 months, but guess what gave her away?
Don't know.
She came back almost immediately, and everybody realised, even at night. So there were 3 o'clock in the morning firing.
Oh, right. So she didn't sleep.
If that was a human, you wouldn't get that level of response. So, and plus it was an AI.
I don't know. I'm an insomniac, Pete. I've often done that. Students have stayed up to 2 o'clock in the morning. Is that? Have you come to the last slide? Where are you?
I've got one slide left. And this is a piece of work I'm doing at the moment. So I'm in a program for a startup business, which is basically building project management software, which is highly automated, highly personalized, to allow project managers to deal better with people instead of looking after process. And what I'm working through at the moment is this bit of work by Professor Vasant Dar from, I think it's in New York actually, who did a piece of work around what are the ideal areas for AI or machine learning or automation, whatever you like. He coined the phrase intelligent automation. So stuff that is south of that line is stuff that is highly predictable, but if it goes wrong, it's not risky enough, so we can automate it. Stuff that's on the other side of that line has to stay with humans. So things like long-term financial trading, diabetes prediction, and driverless cars is just the wrong side of risk at the moment.
Yeah.
But that's changing all the time. Now that line isn't fixed because our appetite for risks as humans will change. So there's a great example of why we can automate fast food, credit card fraud detection. Unbelievably, cataract surgery is a good, and there's robots at the moment that could do all of that. Is a good candidate for automation.
Okay.
Right, so that's my last slide, I think, on there. I don't want to...
I'm going to show the audience now my setup here, because I've got another camera fed into the studio setup. I've got so I'm just going to talk them round that, and then I'm going to talk about general AI, because you said something that interested me. You said that about
just one thing.
No, oh, I see. That was a. Was that supposed to be funny, was it? Anyway.
You use your sound effect, I'll use mine.
Right. Is that like a siren? Right. If you're watching now, you can see me sideways on. It'll probably come into your feed in a minute, Pete. You'll be able to see it. But basically, this is my setup at the moment. I've got over here, I'm watching Facebook through another channel, and I've got the sound effects over here. So if I play the piece of music, this is technical news. So you can see I've got sound effects on this side. Over this side, I've got the broadcast studio. I've got the microphone obviously and some speakers in front of me, but this is what controls everything that's on these two Mac windows here. I've got them all captured on broadcast screen so I can flick between them. It's a good use of technology. It's totally free, this technology. I love it. This is what I really like. This is the thing about AI, and this stems onto that, is it's a great thing with open source at the moment. There's a lot of open source neural networks and things like that. But I want to pick up on something about AGI now. I'm going to go back onto my normal view so I can talk to camera. So AGI, I don't even like the term AGI because one, it says artificial. Now, if we created a life form and it did become sentient, say we reached the singularity, I'm going to talk as an agnostic atheist now, right? Because I think the God hypothesis is the wrong way round. I think we always create things that are better than ourselves. So it makes no sense to me that an all-empowering being makes small things like ants that it can't even barely communicate with because it's such a massive brain. What usually happens is, as in evolution, smaller things like primeval ooze evolves into better and better things. There are regressions in evolution. That means that sometimes things don't always go right, and you get a trait that's not really useful, or we have appendix, and we have all sorts of things that are not really useful anymore. We've even got tails back there, which we don't use anymore. But so artificial. Now, there's nothing artificial about what people are creating, because it would say that it was. You could say it was artificial in a way, but it's from the natural world. Everything is made from the world, and if we made something that was sentient, it would be better than us in the end of the day if it reached the singularity. So therefore, it would decide our future, not us deciding it. So that's one thing. The other thing is the word general intelligence. General intelligence is problematic to me. Basically, we don't really understand human intelligence at all. We don't understand consciousness. So how on earth can we build systems that are conscious? Now, there's some emerging thoughts out of here, and it goes into, and this is why it goes into a bit of philosophy now, and that is the two concepts that a lot of transhumanists look at, and a lot of them are philosophers. They come from all sorts of disciplines. If you don't know what transhuman is, people, it is the merging of technologies with humans to not evolve. That's the wrong word. It's not evolving the human race. It's enhancing, augmenting humans in order to go to outer space, to get rid of disability. It's not just about, at the moment, all augmentations, because we have I've got one contact lens in there. People have got hearing aids, they've got pacemakers, they've got like prosthetic arms that have got some sort of intelligence in them. They're doing experiments at the moment where AI is looking at brain patterns when pictures are put up in front of it, so it can have it's trying to get some sort of neural link. And an interesting thing about that is that the Parkinson's patients have been experimented on, and they have an implant in their brain which interrupts all the signals that are making them shudder, and it's switching it off. It's counteracting that. And they asked them an interesting question. They said, and it goes for anybody that's got an implant or something that they have to rely on that's been implanted in, even myself with contact lenses, is that they somehow become part of you at the end of the day. You bring them into your body and they become the essential you. Because me that used to blunder around, I don't like wearing glasses, but when I used to blunder around, that made me less confident, that made me a lesser person because I wouldn't do that. But by being augmented, it gives you a new confidence.
Yeah, no, just a quick one. The transhuman stuff's really interesting because it's not just one or the other, right? So there's a lot of work going on in medicine and biology, and gene mapping, great example of, and we've got real ethical questions that we need to get over around. We have the ability now to fully map the human genome at birth and tell you if you're going to get Alzheimer's, or if you're going to be susceptible, or if you're in the upper 10% of people that may get Alzheimer's in the future, and it may fix that. China's had big advancements, but they're working with frogs at the moment, so they're taking out certain genes in frog spawn before tadpoles become frogs. So they're doing it with amphibious animals, and it won't be long before they're doing that with us, but we've got real ethical questions to answer there. And I guess people who believe we're here with all our faults, and we're put here for a reason with all our faults, as in people that believe in God or non-atheists, might really struggle with all of that. Paul McCarthy's got a question.
Hold on, what's it say? I haven't picked it up. I can't really see it. Can you see it?
Yeah, I'll read it.
Oh.
So Paul says, serious question. As the human risk appetite evolves, could AI be used to manage the response to a natural disaster such as a bushfire? I think Paul volunteers in that space.
Yeah,
And organises.
There's already inroads into that, and this is part of what I want to talk about. It's the treatment of such. Yeah, we will be able to deal with bushfires because in the end, I think the best use, the quickest way to a artificial intelligent machine is to merge with humans, because we're always worried about robots having no feelings and being sentient and things like that. If we merge together, imagine having a protective exoskeleton and also all the properties. Now, interestingly, I wanted to bring this up. It's a good segue into this. There's nanomorphic material. Have you ever heard of nanomorphic material? It's being made by the US Army Research Laboratories. And what they're doing is they're trying to mimic the materials in the brain and the way it passes message rather than binary computers. It used to be that quantum computers was going to be the answer to AI, but they're not so sure now. They're not so sure. They just need better ways of sending signals, and I think it's too much for this podcast, but they're looking at the moment, we have lots of ways to learn and take in information. We have sight, we have hearing, we do procedural learning, we do predicate learning, we have memory, pattern seeking. What AI can't do at the moment is bring that all together at a level of abstraction which makes them see the overall picture. They can only go into the weeds and deal with one thing at a time. They can't see the big picture. So if you drop something into a neural network and it recognizes a pattern, it doesn't know what the pattern is. It's the software or the person that gets the results that knows what it is. It's the same with a rule base, a knowledge base with predicate logic where you've got rules and facts. That's all it runs off, a procedural program full of rules and facts, an inference engine that churns out an answer when you throw it in there. There's nothing that connects everything together. So what I think is machines will be able to do it. Whether they'll be able to deal with it in the future depends on whether we reach the singularity, because we are taking it as read that we are going to make intelligent machines that will be as clever as us. At the moment, people are fooled. They think computers can do things much faster than us. They can computate things and they mix that up with intelligence. No, that's just like doing things at lightning speed. That's all it is. And just like you said with your machine learning and that, it's not really intelligence there. What it's doing is data mining and pulling the information together. It's using what are called nodes on graphs and trees, and it is actually weighted answers. So it's a probability of something being something, comparisons. But we haven't got what humans do. Look at clouds and see faces. We see patterns and we infer from experience at lightning speed all these things and put them together and we represent our world by that. The one thing I wanted to talk about while we were there was the two schools of philosophy that have to come into play. One is dualism and one is monoism. And before we can get some sort of AI, we have to get over where does consciousness, where are we in here? Now, dualists think that the body and or the soul or the body are different. So what is you in your brain is separate from the material stuff there. Now, monoists are materialists. They believe that you destroy the brain, you're gone. You mess up the chemicals, you're gone. Now, before we can make any AI or mimic it, we've got to understand how the brain works. And the only way they've done it at the moment is that they've had 12 volunteers, and I like this one because I like blondes. They put pictures of things like that. They put a picture of a blonde there, and they did it for all 12 people, and they looked at how AI did this, not people. AI, there was all the results were dropped into neural networks and all sorts of pattern recognition, and they tried to work out whether they could predict what these people were thinking about, whether they knew what picture they were looking at. And it works, but only under narrow parameters and well planned out structures. It can't do it for general things like looking over there and seeing an ant, random things. It has to be set up so you've got 10 things that could happen, which ones happened, rather than then wandering off and then taking their brain patterns and picking it up. So I just got to say, where do you stand on the dualist monoist? What do you think? Where do you think it lies? Where do you think we are?
I'm really concerned with practical application of narrow AI, really, and I'm a bit of a fantasist about sorry to use the phrase, but general AI. So I have not really,
So you're more like
really
science fiction end of it. In the transhumanist world, which I'm a humanist myself, but I also subscribe to transhumanism and doing that. I would love to be.
You didn't say that you were a human yourself.
No, a humanist. I want to be upgraded to an H+, actually. I'm going to miss the human bit out.
I was wondering whether you were going to actually tell me that you were a human, because I've not seen it historically.
All right, thanks for that, mate.
So before we go off on that thread of thought, I've got another one for you, and I think we.
Well, do you want to wind back a bit?
A number of years ago. Oh God, here we go.
Go on.
I have a bit of a motto in my life, which is if you think you have it, right?
Yeah.
And I think I mentioned that to you, probably a Facebook argument there a couple of years ago, where I said, if you're convinced, absolutely convinced that you have something and you have the emotions as if you have it, and it's more than the positive thinking bit, then your body reacts to all of that. Your brain reacts to that. The hormones coursing around your body react to all of that. And, I kind of believe that works. And interestingly...
But that would make you a dualist. That would make you a dualist, because you're saying the mind affects the body as a separate entity.
Could be. Let me go to the end of this, and then you tell me which one I am.
Go on then.
And interestingly, I read a piece the other day, a bit of research that talks about. Hang on, somebody just tried to phone me there. That talked about augmented reality and the future of that under a general AI, or even a more advanced narrow AI, would be such that if you've always dreamt about owning a house in Spain or the Mona Lisa, augmented reality will give you that. It will give you the emotion as if you have been that collector, or you've earned enough money to live in Spain. It's a bit like the holodeck in Star Trek, right? When they used to go on R&R on a break, they would sit by. So if you have that emotion, so that's probably what you're talking about in the dualist sense.
Yeah, well, what it means is if you can separate your body from your mind, that you don't have to be a dualist to do that, because you can be put to sleep and dream, or you can be in a coma and do that. The other thing that's really interesting about AI on that side is how do we deal, and your point's very good actually when you talked about a simulation, because what would happen if you woke up one day and you died, but you'd been cryogenically frozen, and you woke up but you were disembodied, you were in a machine, and you'd lost your body.
There's a Netflix series on at the moment about that. I can't remember the name of it, right? But it's on the second series.
But most of the science fiction comes out of like thought experiments. People actually saying what if situations, like we used to do in the military. What if this happens? What will happen then? But the fact is that I'll give you an example. A beautiful girl gets acid thrown in her face. She's a top model. Gets acid thrown in her face. She was outgoing, gregarious, all the nice things, and her body changes drastically. Take away the trauma of that event, the person changes after a time. And I won't mention any names here, but we know a certain flight sergeant that we knew that was knocked off his bike and completely changed personality. There's also a split brain patient who's interestingly an atheist and a theist, depending on which side of the brain, because it's got a disconnect down the brain. So sometimes talks as somebody who's a believer, sometimes not. So to me, that means it's a monoist, because a monoist is somebody where the brain is embedded. But your simulation, if you're in a simulation, which we could do, that's the simulation theory is another branch of philosophy that they talk about. Way before simulations, other realms, people existed in a fantasy world at one time before they had the holodeck scenario. Would it matter? Because somebody said to me once, what happens if you're in a simulation now? And I said, well, if all the physics works and my general life works, I don't care, because this is all I know. It seems to work by rules. I can't fly. I can't do anything at will. So this is the world as far as I'm concerned. And it's a material world. It may not be real. It may be run by a teenage kid who's playing some game or something. So I think that, going back to my point about AI, general AI, is that we're nowhere near it. We're absolutely nowhere near AGI at the moment, general AI, because of the fact it's just like a blind man leading a blind man in an area they've never been before and trying to navigate round and travel 1,000 miles. It just wouldn't work. They'd end up anywhere. And I think at the moment we're stabbing around in the dark at trying to make this work. We're doing things like the Turing test that's been beaten so many times they've had to revise it. There's other tests that say, well, when we've done this, when you can have a conversation with somebody on the phone, like your experiment with the virtual tutor, the one that was there, then maybe if you can fool somebody, that's AI, it's intelligent. No, it's just a very clever program. So AI will be the day that they go, and there's the old joke, isn't it, where what would you ask a super AI? What would you ask them? What would be your question? And he said, I would say, what's the meaning of life? How did we get here and all that? And the AI gets in a spacecraft and just leaves human race saying, you're all just too stupid to exist. So basically, I don't think it would be interesting.
Elon Musk.
Yeah.
There's a theory that Elon Musk is just an alien who's trying to get back to the planet.
If you listen to his lectures on AI, he's really skeptical. He's like Stephen Hawking's and aliens. He doesn't want he doesn't want to produce them. He doesn't, because he feels that we quickly lose control. It's not about, and that's why Sophia, that project is going ahead, because they want to build into robots. It's just an art project at the moment. But but they're trying to make them more empathetic from the beginning to humans, so that when it does happen. Now, the theory is, how do we make intelligence? We may do it by mistake, because one of the theories of the monoists is that they reckon that there's a tipping point. When you have so many systems going on like humans, there's a certain stage you get to where intelligence just emerges. It just emerges from the complexity. Now, we could have an AI, but it might be planet-wide. It may be the internet. Now, I'm going to revise the word internet, because I'm going to make a bit of a prediction here. With 5G network, which is really significant for AI, really significant, I would say it's not going to be an interconnected net anymore. It's going to be a grid, because they have to be placed so many 100 meters apart. So you're going to have what is called a national grid of connectivity, and that's going to be talking to AI cars. They're going to be talking to each other and predicting what could possibly happen miles before they get there, and everything's going to be automated to that degree.
There's a question from Joe Corns, and I'll
go on back on there.
But one of the things that I talk about when I'm talking,
what does he say first?
People about machine learning and AI and basically image recognition. I ask people, I mean, you've got grandchildren, right? You've got young grandchildren. I've just become a grandparent 6 months ago, and I always remember.
I've got 4 grandchildren.
Sorry?
I've got 4.
4.
Mm.
4. you sit down with a child, and you show them the book of animals, and you show them a cow, and you play that game where you go, what noise does a cow make, moo, etc. And actually, babies and children pick that up really quickly. You probably can't remember, but it took 1 or 2 goes through the book, and then you can recognise a cow. And then and behold, you're driving through the countryside. Hang on, let me finish.
Go on.
Let me finish.
I'm going to write that down, hold it.
But in terms of machine learning, there's a thing called supervised learning. There's a couple of machine learning approaches. One is supervised, the other is unsupervised. And there's another called recommender systems, which Netflix uses to recommend films to you. But anyway, in supervised learning, you're actually showing the algorithm a picture of a cow, which is essentially a grid of grayscale pixels, and you're labeling it. So it's labeled data. So every picture of a cow that you show it has a label of a cow, and you're showing it thousands and thousands and thousands of pictures before it can reliably, 90% of the time, say, yes, that's a cow, or yes, that's Joe Corns' face, or Steve Regan's, or Pete Wilson's face.
Yeah.
But babies and children, we pick that up much, much quicker than they do. So for me, that's where we are with all of this. Notwithstanding, that's a narrow AI, not even a general AI. You were just about to disagree with me.
No, what I was going to say is you came up with a very, very good point, mate, because when we produce robots or AIs like Siri or anything like that, they're always adults. That's not how we should be teaching them. What we should start off with is something like a child. The AI.
Also women.
Yeah.
They're also women.
Yeah. Well, there was Watson and there was other ones. Yeah, but that's because it's an art project. It's an art project meant to appeal to people. So, but
I just said Siri and my phone. Siri's just come off of my phone.
I've remotely turned Pete off. No, but I'm saying that
I've got an echo behind me. It's no doubt it's going to kick in as well. So Joe's question was more of an observation. We can trick the brain with phantom hand experiments, so we are very susceptible to believing augmented reality. That's a bit like a Trev observation to me. I don't understand it.
No, what I think he's saying is that we have limited perception as humans. We are very blind. We've got a part of our eye, if you remember back to the day rods and night cones, that we are actually blind in. And you could do the monkey walking through the auditorium experiment where you're watching a group of dancers and a man in a costume walks through and you don't see them because your attention's shifted. So human perception is awful. The trouble is, though, trouble is that if you had a transhuman, that means a human that had sensors on them, they'd have radar precision. They would pick everything up, and that's the problem. We're not designed, our brains, to pick up that much information and process it. Imagine somebody said, what if you could remember everything? That would be a bloody curse, wouldn't it? To remember all the bad things that happen to you. We have a memory that deliberately fades away, and our mental health goes wrong if it doesn't. If we go into, it used to be that if you're having a trauma, you'd sit down with a counsellor and talk about it, and they would reinforce those memories. But now it's diversion therapy where you're trying to shift people away from it. So there is a problem with there's a problem in developing things where we become superhuman because we've got to cope with our new abilities, and they can be a curse. A really good program to watch. It's a manga. It's Ghost in the Shell. It's not the actual film Ghost in the Shell, but it's the cartoon. That really goes into the issues of what it's like to be an augmented human. And I think he says the phantom hand experiment, and we find disembodied thing. Yeah, I think he means that if you get a knife and fork, say you get somebody with no hand, you put an artificial hand in front of dinner, they begin to think that that's their hand. And they can start, if somebody stabs it with a fork, they go, ow! And it's not their hand, right? But that's what I'm saying about augmenting humans, our prosthetics, our extra limbs, our exoskeletons, our ability to breathe, not need to breathe air or breathe liquid so we can do work in different environments, will mean that it will quickly become part of us. But what will we become? How will we look at meatbag humans that are not augmented? Will there be a new class of how well augmented? And the really thing that worries me, and I touched it on the video, and this is a real point of contention, is, well, look what happened to cosmetic surgery, all right? It was there, it was a brilliant thing when it first came out. People were burns victims, disfigurements, they did that, and then the cosmetic industry, and now you get these people that are shelling out the money. So it's the people with the money that drive it now, and I'm really worried that market forces and money, it will become about money.
Just to bring it back to today, right?
Yeah.
Because I think most experts say if they unit averaged everybody that's working in this space along, people like what's his name that we just talked about, that's an alien who's going back home. His name's just slipped my mind.
Well, Elon Musk.
Elon Musk, right? So they've all got together. They have a forum. I can't remember the name of it, but they all got together and they got all of their teams together and they agreed that we're at least a generation, 50 to 70 years away from all of this, even though it's getting work. It's not getting, it's pet projects for the likes of Google, etc. It isn't being worked on seriously, apart from in academia, because if there's no immediate return on it, the money is going into machine learning and narrow AI solutions, the first of which would probably be autonomous vehicles. Now, that's not just cars, but coming back to Paul's observation about how we deal with bushfires, Amazon are doing work at the moment with an autonomous vehicle that, so they waste an awful lot of money at the moment with people pick up a van, they go and say, right, give me a round of parcels, I'll go and deliver that. And somebody sits there with a map and says, can you do that round? Can you go down that side of the city? All right. We're doing experiments with now where that will happen automatically with automated self-driving trucks. It will also have, so the big problem is delivery into the countryside is a bit of a nightmare. So they need a mapping technology that parks the truck in the exact right place, and then 5 autonomous drones take the parcels to where they need to go to, drop them in the garden, come back.
Drop them on the baby.
That's live technology right now. It won't be implemented until our risk appetite is such that we're happy with self-drive trucks on the road. But now you can see how that would work in the likelihood of bushfires, where you can't get fully autonomous. You can't get humans into spaces because of risk of life. They can get in there. The autonomous drone flies off, sees where the hotspots are, the literal hotspots. Then the fire tender, which is full of water, can get in there, and then come back, fills up again.
Sounds like international rescue, mate. Sounds like Thunderbirds.
Well, absolutely, but all of that technology is there right now.
Yeah, I just want to pick up on something about risk. I'm going to take it further. You talk about the risk of why things aren't getting taken. I'm going to talk about the insidious side that people think technology is against them at the moment, and it's down to AI, algorithms, and things like that, like Facebook feeding you with information all the time and making bubbles of people, feeding back information. They talk about Google always targeting advertisement at you, and I was listening to a very interesting podcast. I can't remember his name, but he talked about the fact that there are very good people in Google and Facebook that make these algorithms. It's the unintended consequence of their delivery that makes them insidious. Like, it makes you think that everybody's watching you and you're being monitored, and some arbitrary algorithm comes up and bans you for 28 days on or 10 days on Facebook, when it's just an automated algorithm that's been told to search for a narrow amount of parameters and stops you. So I think it's not just risk, it's people's mistrust of technology. And it's just that we can't control it. It's just like a virus. We send a virus out, or the people who invented virus can be infected by their own virus. So we've got to be careful when we create things, because I think a bigger danger than the atomic bomb would be to create something we lose control with that has the capabilities of eradicating us.
There's a couple of models around the general AI, and one of those is the Oracle model, which is a little bit like if you watch the series The Vikings.
Yes.
Where they go into
the seer.
There's an old hag. They're going.
Yeah.
So the Oracle model is it's in a mountain, locked up. It's not connected to the internet or anything like that. You switch it on, ask it the question, switch it back off again, and then visit it when you want to know the meaning of life in another 100 years.
And then, remember the 2000 Space Oddity, where Dave turns around and flushes them out of the airlocks because he finds out, he reads their lips and finds out they're going to switch him off. So he flushes them out the airlock. I can see the Oracle. I can see them going up to the Oracle and going, right, okay, we need deep thought to tell us the meaning of life, the universe and everything. And they go to hit the kill switch and it turns around and they become a puff of smoke.
Yeah. Just touching that, so just before we finish, Paul's asking about education, and I've done a session with education in Northern Ireland around AI and what the future of that might look like. So in the short term, there is some stuff that's going on in that space to enhance the learning experience through AI, but they can see in the future that, and Steve, you're in this space already.
Yes.
That. There are schools in America where all the human teacher does is brings people together as a team and gets the socialization right and enables them to work together as a team. And then they go off and they do videos, they talk to a screen, they work on their own, and then they come back once they've learned that and taken their little test at the end of a session. And there is a thought that in future there'll be one-to-one training, and all that humans will have to do is pastoral piece and making sense of what they've just learned fit into the normal world. Because one of the things that AI is good at is reading body language, temperature, facial expressions, and emotions. Now, if my teacher could read my mind in such a way when I was like 14, they would have known that I was really struggling. So, I think in the future there's going to be tailored education per individual by their that teaches at their pace and can very much identify the strengths and weaknesses in people. Steve, I don't know what you think about that.
I think that you're quite right. Now, it will lend itself better to certain subjects. I think it really lends itself well to subjects like computer science and technology and maybe mathematics and things like that. I think the more creative subjects, it might be a difficult thing. I would say human subjects that you would have to have some human contact with. I think we'd lose that. We need, for our mental health, we need human contact. I don't think machines is ever going to replace that. I think there's going to be something when we have autistic children and they can't interact with you well. It's a bit of a stagnant conversation, no matter how and they usually are quite intelligent. It's not intelligent that makes you endearing to other people. It's that empathy, that sort of emotional intelligence. And I think that's going to be very hard to do. Anyway, I think that's about it now. All I'm going to say is thanks, Pete. This has been great. And if you're up for it, I'd like to do this quite regularly and pick up a different subject, because I'm starting a new business. If you look down on the logo there, it says Online Learning CS. That's my new tagline. I'm already making a 90-hour, a 30-hour and a 20-hour course to go on Udemy, Skill Up and Teachable. And also I've got a monetized YouTube channel as well. it's really a part-time job because I've got a teacher pension and a military pension to live off, and somebody's a primary teacher and a senior management who can keep me in pretty things and make sure that I'm happy and fed and watered. So basically, I'm going to be a very busy person. I've got the charity to run as well, which is really important to me, and becoming more so. But I would like to carry this on because I think there's a lot of explorations, and I would like to we've got two muse, that's two of us, to muse on things, and it doesn't always have to be, we can touch on, as long as it's technology-wise, I think we can touch on anything, really. So I think we're not
short of opinions.
Oh, no, we're not. But, I think it's been great, and I'd like to thank everybody that's listened to this. We're going to get better at it, I think, in the future. I think we've made a reasonable job today, and I've really liked your input, Pete. And thank you for everybody else that's watched. I'm going to play us out now, but I'm going to put this onto podcast platforms, onto YouTube as well, and the edited version will be on Facebook. And Pete, you're free to use this on your blog. You can have a copy of it or use the YouTube link, whatever you want to do. So we can take in the comments section, I think it's a good idea if we get fed topics that the audience want us to talk about. And sometimes if something's happened to us or something topical comes up, we can choose that. So do you think we ought to do this once every 2 weeks or once a week? What's your schedule like?
For me, right now I'm working a lot from home on the startup. So I was before the plague, travelling back to London and here and Dublin, but I'm pretty static at the moment. So yeah, we could do a more political, economic, social one next if you want.
Yeah, my channel, I've got to admit, this is all part of my business model to get out there and my opinions out there. So technology based, but there is technology gets everywhere, and if we can put an angle on it, that's okay. So I'd like to give a round of applause for the audience. And congratulations for our first podcast, to Muse. That's two of us, Pedro and Rocky. And I'll just play you out. I'll chat to you when we've come offline.
Ciao.
See ya.
Have a shave.